This is a flame sensor, also known by other names such as a 5mm infrared receiver LED or an IR diode LED. It looks identical to an LED and has a short and long leg, but we use this one to detect infrared light emitted by flames. In this video, we are going to learn how we can use this sensor in our projects. So without waiting, let's begin. The necessary components that we need for this project are the flame sensor, a 5K resistor, some jumper wires, and a breadboard, and also the Arduino as well. For the beginning, let's make a simple circuit to detect the infrared light emitted by flame, and get the values so we can make some sort of alarm system later. First, connect your sensor to the breadboard and then connect the long leg of it to the 5V of Arduino. Then what we are going to do next is to connect the short leg of the sensor to the GND of Arduino, but don't forget to use the resistor in between. Otherwise, you might cook the sensor or it might not work properly. Next step is to receive the value sent by sensor, and to do so we can use any analog pins of the Arduino. Connect this wire between the short leg and the resistor, just like I do. Next step, we are going to make a program to receive these pulses. To begin, open up the Arduino IDE. First, we will make the variables that we are going to use later. I'll make two, one for the analog pin and one for saving the values received. Now in the setup method, all you have to do is to start the serial monitor since we are going to print some stuff later. After that, in our main loop, we will get the values received by the A0 pin and we will store it inside our read variable. And next we will print the value to the serial monitor and make a small delay at the end of the loop. Now our code is ready to run. Let's connect the Arduino and upload it. After uploading the code, it's time to test the sensor. Observe how it detects different flame intensities and outputs varying values. When testing with a small flame, you can observe that the sensor typically produces values between 0 and 50, provided you don't bring the flame too close to the sensor. Next, we will test with larger flames to observe the range of values produced by the sensor. You can see as the flame gets bigger, we receive higher values as well. Now we can make some kind of alarm system to turn on different colors of LED according to intensity of the flame. I'm going to connect the sensor to a separate mini breadboard to avoid damaging my other components while working with the flames. Just connect the sensor and also a wire to each leg, and the rest is same as previous step. Now we are going to use three different LEDs, a green one for a light flame, a yellow one for a medium flame, and a red LED for when the flame appears dangerous. You can create a common ground for all the LEDs by connecting their short legs to the common ground rail of the breadboard. Before doing this, connect a wire from the ground rail to the GND pin of the Arduino to complete the circuit. We will use 220 ohm resistors to control the current going to each LED. Next step, I'm going to use Arduino pins 8, 9, and 10 for communicating with LEDs. Connect each resistor and LED and wire as I demonstrate, and you will be all set afterward. Also, don't forget to connect your analog wires to be able to get the values. Now it's time to do some modifications to our code to detect the flames and turn on the LEDs according to the intensity of flame. First steps are the same, only this time I'll make 3 more variables for the 3 different LEDs. You can also find the codes of these projects on my GitHub. Links are in caption. In the setup method, we need to initialize all the LED pins as output. Also, don't forget to use the method serial begin. Now again, in the main loop, we will first get the values of A0 pin and then we will store it in the read variable. Also, we can print it to the serial monitor if we want. In the previous test, we observed the different values produced by the flames. Now, based on those values, we will determine which LEDs should light up at specific value ranges. For example, when the read value is less than 10, we keep all the LEDs off. When the read is between 15 and 90, we will turn on the green LED. These values may vary for your setup, so you'll need to test and gather your own values. Also, when you turn on one LED, don't forget to keep the other ones off. In order for the yellow LED to come up, we need to get a value between 90 and 170. And the red LED will turn on only by the values more than 170. Make a small delay at the end of your program, and everything must be set to run. After uploading the code to the Arduino, now I'll test it with 3 different lighter. As expected, with the small flame, only the green LED turns on, and if we get closer to the sensor, the yellow and red one might turn on as well. Now we can continue the experiment with larger flames and see if the sensor detects them as dangerous or not. You can see that with big flames, red LED turns on as well. If you enjoyed this video, please like and subscribe. Also, share it with your friends so they can learn something new too.